Welcome to Global Wheat Detection Kaggle competition, where we, as a community, as a group of people, look at a bunch of images of wheat and detect if the image has wheat or not. This has to be the weirdest thing I've ever done using computer vision, machine learning, but uh, why not? Why not? Wheat is important. I eat it every day. I just never think about it. It's one of those things. So we're going to be doing wheat detection. It's an object detection competition. So grab your YOLO and Frost RCNN's paper. And I mean, those are all papers. Maybe there are a lot of new papers that have come up. But that's not what we're focusing on in this video. What we've looked at up till now is we've looked at the data, which is basically what we'll be doing in this video as well. We've looked at the data, how much data we have. We've looked at the images. We've looked at the data, how the data looks like. And in this video, I think we're going to be covering something that's the most important thing, or that's essential for you to be able to have any success in the competition, and it is resizing images. That's the code we're looking at. And if all the code that I show in these videos are available in my GitHub repository, I should be linking it in the video description. If it's not there, just comment on the video and remind me. So in this video, we'll be looking at resizing images. Now, why do we want to resize images? Well, the great thing about the data set is that all the images are of dimension 1024 cross 1024, which means each image has a million pixels. Well, actually it has three channels, so it has close to 3 million pixels. Each pixel is not uh, it's not uh, an integer, it's a floating point number. It has, so basically each image is, well, there's just a lot of pixels and a lot of data points, and there aren't enough images because we just have around 3400 images with only 3300 images that have bounding boxes. So we have to resize. I mean, if I remember correctly, YOLO paper, in the YOLO paper they had millions of images. They also had a lot of, maybe not millions, but 100, at least 100,000 images. I don't remember that. And they had many more classes than we did. We just have one class, which is wheat, but still 3000 images is not enough data, and we have to resize because even they use 224, I think 224 cross 224 sized images, which they then blew up to twice the size. But yeah, it's just these images are too huge to be used as it is, which is why we're doing some resizing of images. This is the resizing images code, and here we have, so a bunch of libraries I use the CVideo library. Then this portion of the code. All of this is from the previous videos. There's nothing new here. And then there is a function I defined called rescale images, which rescales the image to a particular factor. I've also tried and documented. It basically just rescales the image, returns the resized image and the new bounding boxes. Because if you resize the image, you have to also adjust the bounding boxes corresponding to the resized image. And just to show you how things look like. So what I've done is I've picked one image and I rescale. I call the rescale image function, and I rescale them by different factors. And let's see how they look like. So just to blow it up a little, the first one, so how we're resizing it is by factors of 1, 2, 4, 8, and 16. I write the resulting size of the images by factor 1 is just 1024 cross 1024. Then this is 512 cross 512. This is 256 times 256. This is 128 times 128. This is uh, 64 times 64. So let's look at the first image. This is 1024 cross 1024. Crystal clear. I really like the image. If I was a photographer, but no, we're into machine learning. I don't think we like the image. I don't think even a photographer would like the image. But yeah, it's more clear. It has more detail. But do we need that much detail is the question. So let's look at the next image, which is reduced by a factor of 2. You could see the x and the y axes, they only go from 512 plus 512. The previous one went from 1,000 to 1,000, and this image looks fine to me. I mean, like I could it, detect weeds with eye. I mean, this looks really good actually. Let's look at the next image. It's 256 cross 256. Look at the dimensions. Not reduce the size, but the dimensions decrease. Okay, it's starting to get blurry. It's also starting to get blurry because we were comparing the images, like the box square length is the same, but the number of pixels are decreasing, which is why they're starting to look bad. Because if we had the original sizes, you would not see that these pixel basically the image is pixelating right now, but you wouldn't notice it. 256 cross 256 is really good actually. It's good enough. Uh, this is 128 cross 128. This definitely is pixelating, but it a part of it is that there aren't too many pixels. A part of it is also that we've blown it up too much. And this is 64 cross 64. Now this is legitimately pixelating, no doubt about that. This image is pixelating and really badly. So part of the reason again is that we've blown it up too much. But I think this could be enough for our neural network to recognize if there is wheat in it or not. I remember I did a face recognition project on faces that were really small. Those were images taken by phones, so they were like the images were 30 cross 30 pixels or 40 cross 40 pixels, like really small images. And you know what? I could not make out the face of the person looking at the image. I would blow the image up and the image would just pixelate and burst out, and I could not recognize the how the person in the how the face of the person looks like. But the neural network I created was able to do the classification of faces, face verification as well, pretty nicely. So uh, if it doesn't look good to you by eye, doesn't mean it's not good enough for the neural network to give decent results. So there's another thing that I'll do here is because I've blown it up too much. I wonder if that's the case. I will call this function again, and I will try and just show you the 64 cross 64 sized image in its original size. So let me try and do that. So this is how it looks like. Well, it's still bad, but not that bad. Uh, let's look at it. Let's look at these in their original size. So this is by the way, this is in their this is still blown up, but not as blown up as it was before. Uh, and this looks pretty good. This still looks good. I mean, I would say that a neural network could actually go down one, I mean, a little bit further as well. So yeah, this might look bad compared to these two, of course, but that could also be because they've been blown up a bit too much. Let's say I reduce the size even further. Say I have a size of 5 cross 2. Huh. Is it bad? Probably. I would so I think this is my tip for you. I think this is something. This is basically the factor or the scaling factor is a high parameter. You have to play with it, but I would not use a scaling factor of one, which is by which I mean I would not use a 1024 times 1024 sized image. Maybe a 32 cross 32 image is a bit smaller than it needs to be. But well, if you look at it, a 128 cross 128 image is good enough to uh, work with. So definitely never ever go above 512. 256 is the maximum you should even try with. Even if you have a 256 cross 256 image, the first layer of your neural network has how many? 256 times 250, it's about half a million parameters. Your first layer, I mean, like first, depending on how many. Am I right when I say this? I'm not sure. Okay, so I haven't thought about it, but don't nail me down on the numbers, but yeah, I wouldn't go beyond 256, and my preferable numbers would be 128 cross 128, 64, maybe even 32, maybe, who knows, maybe even 16 cross 16 might work, but yeah, 128 seems to be the right number to start with. So yeah, this was it. This was the resizing video. Resizing is really important. Uh, don't even think you could just use the 1024 plus 1024 size images and you do good in this competition because there isn't just enough data. So yeah, this was me ranting about resizing, and that's all for this video. And in the next video, we'll be looking at the data loader and making the data loader for our code. And yeah, so this is it. I hope you liked the video. I hope you found it useful. If you did, please hit the like button. Please subscribe to the channel. I'll be posting more videos on it. Comment and let me know what else I can do. So yeah, thank you guys and see you on the next video.